This type of pattern question is not so common. It's actually quite simple, but since it doesn't come out that frequently, it can sometimes catch you off guard. To avoid this, it's good to have a list of pattern types to look out for, which I will cover in my overview video on patterns. I'll place the link in the description box, or you can look for it on my YouTube channel. So how do you identify this type of question? The most natural tendency is to look for the difference between the terms. Observe that the difference is not constant, but there's a pattern in the difference itself, because the difference keeps increasing by 2. Ignore this, it is misleading. Yes, there is a pattern, but it's not very useful to us, because you can't derive the term from the figure number itself. You have to manually go down the entire list just to find your answer. Except for students in the gifted stream, they may be taught how to derive the quadratic equation behind this pattern. Since the second difference is constant, it forms what we call a quadratic pattern. But let's not go there. Let's eliminate simpler solutions before we resort to the nuclear option. Try dividing the term by the figure number and write the quotients beside the figure numbers. So 10 divided by 1 gives us 10, 22 divided by 2 gives us 11, and so on. Next, find a link between the quotients and the figure numbers. There are usually only 2 ways to try, multiplying and adding. If we multiply, we can see that 1 times 10 gives us 10, but this relationship doesn't hold for the rest of the sequence. If we add, we can see that 1 plus 9 gives us 10, 2 plus 9 gives us 11, and 3 plus 9 gives us 12. So we have found a link between the figure number and the quotient. So for figure 12, the quotient must be 21, because 12 plus 9 equals 21. So to find the term, we use the figure number times the quotient, or 12 times 21, which is 252. We also need to know how to find the figure number if we are given the term. Since the term is 682, we know that figure number times the quotient gives us 682. We know that the quotient is figure number plus 9, so we can write figure number times figure number plus 9 equals 682. It looks like we are stuck here, but notice that the figure number and the quotients are actually not that far apart. The difference is only 9. This actually resembles square numbers. Remember that anything times itself gives you a square number, so 2 times 2 gives us 4, and the square root of 4 gives us 2. So if we take the square root of 682, we get about 26.1, and this is somewhere in the vicinity of our answer. As a matter of fact, it's very near the middle of the figure number and the figure number plus 9. So let's just try figure 21. This means that our quotient is 30. 21 times 30 gives us 630, so it's wrong but very close. Let's try figure 22. The quotients must be 31. 22 times 31 gives us 682, so figure 22 is correct. Understanding how to solve this question is not nearly enough. You need a lot of practice. It's just common sense. It might seem like a hard question now, but practice it enough times and you'll be able to solve it with your eyes closed. But where are you gonna get enough examples to practice? Spiderweb Math is a website that I've created for my students which regenerates the same questions over and over again and is automatically marked. This way, you can just focus on getting the repetitions in. If you found this video useful, do consider subscribing to this channel and liking this video.